I also just wanted to do one more increasing, decreasing just before we left, and one that's just a little bit different. So let's look at n over 2 to the n. Is this increasing or decreasing? I wrote out a few terms. When n is 1, when n is 2, well, we get the same. N is 3, well, 1/2 to 1/3, we're getting smaller. N is 4, 1/3 to 1/4, we're still getting smaller. Again, I could reduce these, but just to get me in the right direction. So I want this term, let's call this g sub n. So we want g sub n. If we're decreasing, this should be bigger than or equal to g sub n plus 1. But is that true? So we would have n over 2 to the n. Is that bigger than n plus 1, 2 to the n plus 1? I just wanted you to see one that has a little more algebra. Once again, we can't make a conclusion here. This is the bigger numerator, so it feels like the bigger fraction, but it has the bigger denominator, so it feels like the smaller fraction. Still cross multiply. N times 2 to the n plus 1. Is that bigger than 2 to the n times n plus 1? And just the little funny manipulations so that you've seen this. Where do I get started? It's like, okay, fine, I could distribute this. This is n times 2 to the n plus 2 to the n, but how does that help? It actually doesn't really help. It's better if you leave it in this form. Come over here, 2 to the n plus 1 can be broken down into 2 to the n times 2, and now that's actually the clever move. So just to realize, we've done a lot where it's just FOIL it out and then good things happen. But instead of actually distributing this, take advantage. Get this to be a plain 2 to the n so that you can cancel. And now we've got 2 times n. Is that bigger than n plus 1? That's a pretty good line. Even better, subtract an n. And n is definitely always bigger than or equal to 1. So g sub n does decrease. Okay, everybody, again, a lot from this section, a lot to practice and go through, and then you'll see once we get to 11.2 series, we're going to use all of this type of work.